Welcome to this video on the 5 fundamentals of motion control. Regardless of the hardware vendor or software platform you're using, certain core principles apply universally to controlling a servo axis. Today, we'll explore these essential pillars and focus on 5 basic motion commands crucial for operating a servo axis. Let's dive in and unravel the basics of motion control. Most instructions on a servo axis require the drive to be free of any errors. That is why one of the most essential servo axis commands is the reset command. Resetting a servo axis prepares the drive for normal operation by removing any error states or alarms on the drive, and by clearing any active commands or set points that may interfere with new operations. After an axis has been cleared of any faults, the axis is ready to be energized. Before an axis can execute any type of movement command, it needs to be powered on, or enabled, first. After the enable command is activated, the servo axis powers up and prepares itself for motion control. Furthermore, enabling the axis activates position control, causing the axis to start regulating and maintaining its set point position. So, the axis is powered up now. We're ready to start moving, right? Not quite. Although the axis might be enabled, it cannot move to a set point position until it knows its current position. Here is where the homing command comes into play. Homing a servo axis sets a reference position, a home position in the axis, and ensures accurate and repeatable positioning for subsequent operations. There are various types of homing commands, which also depend on the type of encoder used for your servo axis. Generally speaking, there are 2 main categories of homing commands: active and passive. Active homing commands involve moving the axis toward a home sensor, stopping at it, and setting the reference position at this point. Passive homing commands do not move the axis, but instead set the home position at the location where the homing command was initiated. After completing a homing command, the axis accurately knows its position and is ready for the next phase, moving the axis. The main objective of integrating a servo axis in an industrial application is to achieve precise positioning. Positioning an axis involves moving it to a specific location. There are various instructions available for moving a servo axis. Absolute move instruction moves the axis to a specified absolute position. For example, a piston is moved from its retracted position of 5 mm to its extended position of 150 mm. Relative move command moves the axis a specified distance relative to its starting point. For example, a foil stamping machine advances the foil material by 50 mm after every execution trigger. Velocity command moves the axis at a constant speed. For instance, a conveyor belt runs at a constant speed of 25 mm per second. Jog command moves the axis in a specific direction as long as the command is being executed. For example, an operator jogs a vertical lift upwards to adjust the height of the lift to align with the workbench for loading parts. Superimposed move command triggers an additional motion to be overlaid on top of an ongoing movement. For example, superimposing a slight oscillating motion on a steadily moving paper roll in a printing press ensures even ink distribution across the paper. Other types of move commands may also be available depending on the hardware platform you use: Siemens, Rockwell, Beckhoff, B&R, etc. But these 5 showcased before are the most commonly used. So far, we've cleared any faults on our axis, we've enabled it, and we established a reference position by homing the drive. Then we initiated movement using a move command. Now, it's time to bring this to a conclusion. It's time to stop the servo axis. Stopping an axis halts its motion, either immediately or in a controlled manner. An immediate stop command abruptly stops the motion by breaking the drive as quickly as possible, aiming to prevent any harm to operating personnel. For instance, upon noticing a potential crash, an operator presses the emergency stop button, immediately deactivating all servo motors controlling a robotic arm on an assembly line. This action rapidly stops all movements, ensuring the operator's safety and preventing damage to the robotic arm or any surrounding equipment. On the other hand, a controlled stop command decelerates the servo axis smoothly, avoiding mechanical stress on the system or overshooting the position. For example, a conveyor system transporting empty carton boxes comes to a smooth halt using a controlled stop command, preventing any boxes from tilting over. In short, stopping a servo axis is crucial for system and operator safety, providing a way to halt motion appropriately depending on the situation. These 5 basic commands form the core of motion control in PLC applications, enabling precise and reliable control over automated machinery. They allow for handling faults, initializing and powering up servo drives, establishing reference positions, executing precise movements, and ensuring safety through controlled stops. To learn more, check out the motion control and robotics skill paths at realpars.com. You can find their links in the description below this video.